Welcome back to RSA Conference 2021, live from Virtual Broadcast Alley. I'm your host, Paul Asadorian. Joining me for this segment is my good friend, Ed Skoudis, SANS Fellow and founder of CounterHack. Ed, welcome back to the show.
Hey, thanks, Paul. It's great to be here. Virtual RSA Conference. How about that?
Yes, always nice to talk with you, Ed. The topic for today is our recent attacks against software integrity. I want to start, Ed, with I think open source libraries, because this is a vast problem that has like many tentacles. And one great example, when I read the Exim vulnerability description, there were 21 vulnerabilities from the Qualys researchers. There's lots of great technical details, all the points in the source code where it's vulnerable. And I kind of honed in on this one thing where there was one of the CVEs and they're like, this was a bug labeled as a bug by the Exim project, and Debian didn't patch it. Many of the distributions didn't patch it because it was labeled as a bug, but it was a security vulnerability.
Yes.
I feel like that ties into open source libraries as well, because a library or software package can run into this issue.
Absolutely. And, a lot of people think, well, I'm using commercial software for this, so that's not an issue for me. Almost all commercial software has vast numbers of open source libraries in it.
Right.
And
packages.
the thing is, you don't really know that. And which open source libraries? The vendor knows. Maybe. Sometimes the vendor itself is using another closed source project or an open source project that depends cascadingly on other open source projects. And it's not to pick on open source and to say it's less secure. Open source is just the only place we can have visibility into whether fixes are propagating downstream. And the answer is they're not. So if a closed source project uses open source software in it, there's a pretty good chance it won't be updating it. And that's bad news.
Yeah, my other two concerns with open source libraries are, one, what if the maintainer just stops and doesn't tell anyone, really? Like, just basically stops updating it, stops taking pull requests, kind of goes on vacation, they get bored with it, right? My other somewhat greater concern is, what if they pass the torch to someone else and that other person is either a malicious actor or someone from Russia shows up and drops off a duffel bag of $1 million on their front step? Yep.
Or, a lot of these open source projects have, hundreds of contributors. So I'll add a third to your list of two big concerns. Somebody could contribute an update or a patch that doesn't get quite the scrutiny it needs to, and it gets pushed in. Yeah. Remember years ago, 15 years ago, something like that, somebody submitted that update to the Linux kernel. And it was something like, if EUID equals 0, then do something. And Linus Torvalds found that one, because if you do if EUID equals 0, it's not comparison. Equals is comparison.
Oh, right. Yes.
Equals 0 is actually assignment. You're making the EUID 0. So boom, it was a root level backdoor that somebody tried to submit to the Linux kernel. Never made it into any release, but that's the kind of scary thing. You're missing a single equal sign. And again, not picking on open source software. It's just open source. At least we have a chance of visibility into this. There was a great white paper came out last year, and I mentioned it in my RSA talk, which is coming up in about 3 hours, 3 hours and 30 minutes or so. It's called something like this. It's a backstabber's guide to knife selection, which is what a tremendous title, right? So you backstabber, it helps you figure out the right knife. But it covers a couple of dozen different ways that vulnerabilities and backdoors can be smuggled into open source software. I urge everyone to read it. It is eye-opening and phenomenal. It's a really good piece of work.
I guess my follow-on question, now that we've defined this problem in actually a fair amount of detail in 5 minutes.
Not bad.
What do we do about it?
Well, so there's a couple things. One is shining some sunlight onto this thing. And there are tools that can do analysis to see what open source libraries and packages are built into the products that we buy. There's one actually from OWASP called Dependency Check. And this dependency checker looks at all of the dependencies from open source projects that are within a given closed source product and can tell you whether they've appear to have been updated. So, and there's many other tools that can do that as well, but Dependency Check is one from OWASP that's free. There are commercial tools that'll do that as well. So I mean that's kind of a cool thing. The other thing is pushing this responsibility back into the vendors, and I'm sure you've heard, and you must have talked about it on the show many times, the idea of software bill of materials.
Yeah, the SBOM.
Yep. Again, that doesn't solve the problem, but it puts some sunlight on the problem. And I think, increasingly enterprises need to demand a software bill of materials. Not that the enterprise itself is going to go through everything, but forcing the vendors to put their arms around this problem and deliver that information, that's going to, I think, make things better and move it in the right direction. It's not going to fix the problem. The problem has to be fixed by us, insisting that the vendors keep things up to date. But if we have no visibility into what they're shipping us, the analogy I use is this. If you look at the critical controls, from the Center for Internet Security, the number 2 critical control is software inventory. Mm-hmm. Critical control 1 is asset inventory. You got to know which systems you have. Critical control 2 is you got to know what software is on them. But this software bill of materials, and also things like dependency checker that can automated do an analysis of figuring out what's in your closed source software, what that's doing is it's finding the ingredients in the recipe for making a software package. And we need to know the ingredients, just like you need to know the ingredients in what you're eating, right? If you want to eat healthy, you're going to need to know the ingredients of what's in your software.
And that rabbit hole goes deep because there's dependencies of the transient dependencies of dependencies.
There really is. And I think there's opportunity for us here to kind of push the vendors in this direction, and ourselves to start doing these kinds of checks. The XM example you used is a really good one. But it's never going to be perfect. And that's why in my RSA talk that I'm doing in 3 hours, I also talk about the increasing importance of doing threat hunting, because our security is never going to be perfect. You will get people that dodge your very good security even. Mm-hmm. I mean, there's just very sophisticated attackers out there doing really subtle things. This isn't FUD. This is just, you see it in the world today. And they're well funded increasingly by ransomware payments. So I'm really been looking at threat hunting a lot over the last 6 or 8 months. And there's a revolution going on in it right now. And it's really exciting. I like what I'm seeing in the threat hunting community, the tools that are available, and just the innovation and ideas. It's almost like this. Remember 10 years ago, like pen testing was really sexy, and 5 years ago, red teaming is really sexy. I think a lot of that sexiness is now moved to the threat hunting community in a pretty awesome way.
Yeah, I think that ties into session tracking for single sign-on, and also ML algorithms used to detect malware.
Yeah, true. So in this talk that we're going to do, each of us has 6 minutes. So it's 6 minutes of me talking about software integrity. Mm-hmm. Then it's going to be 6 minutes of Heather Mahalik, and she's going to be talking about session tracking and crypto use in applications. Some pretty cool stuff there. Then Johannes Ulrich is going to talk about machine learning and how attackers are feeding bad input into machine learning algorithms so that they're optimized to detect the wrong thing. So really brilliant talk by Johannes. And then we finish up with 6 minutes of Katie Nichols talking about the evolution of ransomware. So it's, 6 minutes, 6 minutes, 6 minutes, 6 minutes, 24 minutes. And then we do another 20 minutes of Q&A. We've been doing this talk, updating it every single year for about 15 years now at RSA conference. And it's really a joy to do it. I love working with, my fellow presenters. You only get 6 minutes, so you got to make them count. I seldom practice my talks to the level of, I'll go through it in my head, but I don't speak it. For the RSA conference,
you have to.
I actually present it again and again and again because it's so short in time. Yep. You got to nail your points. I don't memorize the talk, but it's not far from it.
Right.
Yeah, it's fun. It's intense, but it's. I hope the audience here will check it out. I think they'll like it. The Q&A is the most fun part for me because RSA conference encourages us to answer the questions that were asked, but then also comment on the other panelists' answers. Right. So you get that sort of back and forth. I mean, we're never mean or disagreeing with each other. That said, sharpening each other's points. Yes, it's cool when that comes out of the panel.
And I want to get back to the open source stuff for quickly, and then I want to get your thoughts on ransomware as well. When I interviewed Wheel, and he was one of the researchers that found the sudo vulnerability in addition to
how about that?
XM, right? Mm-hmm. And both times I asked Wheel, I said, what tools do you use? Like, how do you find these vulnerabilities? He's like, basically, there's a team of us, and we crawl through every line of source code in 15-plus-year-old projects such as Sudo and Exim, and we find stuff that the developers and even original developers have not found yet.
Yeah.
Well, what can we do to enable not just the elite research teams like it's happening at Qualys and others, what we can do to enable others to find these vulnerabilities? Because essentially they're uncovering this stuff by just reading the source code.
Yeah, which is crazy, and it's crazy hard to do.
It is.
You see them finding things in like the file command or finding things, it's just in really old stuff. The Sudo thing shocked me.
Right.
So you could say that try to do more automation. And look, they are pushing the envelope in automated source code analysis. Veracode is a commercial company that does a good job with that. But from a free perspective and a volunteer perspective, I would love to see some sort of tutorial, and maybe this exists, I haven't looked for it, but something that might be a 2 or 3 hour tutorial. So it goes into some depth in 2 or 3 hours, because I don't think you can get through this in a half hour, an hour, but a 2 or 3 hour tutorial on, hey, you want to look through some source code of old stuff, probably written in C.
Yep.
Here are some things you should look for to try to find the vulnerabilities to help drain the swamp and also make a name for yourself. I mean, there's a lot of smart young people in colleges who are looking for a way to make a name for themselves as they move into industry and government. So I'd love to see if there's maybe some of your listeners even know if there's a 2 or 3 hour course that's free, so that we could point people to it, so they could learn this thing that's pretty hard. And even then, the stuff that Wheel is doing is you can't teach that in 2 or 3 hours. But I think you can teach something in 2 or 3 hours that would benefit people and help the industry.
I think if you've learned how to program in C, you can benefit from the 3 hour course, right? That'll be a prerequisite. Like, you got to know how to code. Here's how to, fundamentals on how to find the vulnerability. That would be awesome to enable the community to do more of this. Because I think there's so many millions of lines of code. We need more people.
Unbelievable. It really is how much code is out there and how we're still finding fundamental vulnerabilities in it. Marcus Raynham said something years ago that sticks with me to this day, and it makes me sad. He says, we are deploying vulnerabilities far more quickly than we are fixing them. And he used this analogy. He says it's like an iceberg. You see only 10% of the vulnerabilities are above the water. The other 90% is under the water, the vulnerabilities we don't see. And we're rapidly slamming more ice under the water.
Yeah,
right?
Absolutely correct. Ransomware is top of mind for everyone today. Of course, you and I and many of us listening we date ransomware back. Where does it date back to? 90s? 80s even? Right?
Well,
it's got a long history.
There was a book called, I actually presented on this at RSA conference about 5 years ago. There was a book called Cryptovirology. Do you remember it? It was actually based on a paper, and it came out 15 years ago, I think.
Yeah.
And maybe even longer. It might have been 18 or 19 years ago. And in this book, which was based on a white paper that came before, the authors, I forget their names, but the whole book is focused on the offensive use of cryptography. And when it came out, it was hugely controversial, especially among cryptographers, because they said, look, cryptography is supposed to make people freer and better and happier, and you're using it for offense. But this is where I first saw this idea. They didn't even call it ransomware, but the idea of encrypting data and then offering to sell the decryption key back. The book was called Cryptovirology. I remember the book well because it was a great book, very innovative ideas, super scary stuff, but it was printed on the most horrible paper ever. So I read the book, and the paper's terrible, and the ink comes off in your hands when you read the book. Right.
I don't have that problem with audiobooks so much.
That's true. Yes. So, but now the whole thing is, of course, exploded. The Colonial Pipeline thing, all kinds of businesses are getting hit with this. It's crazy.
But and it doesn't seem like there's a very prescriptive way to defend against this problem. I feel like with PCI, when people were stealing credit cards, like we had a way to get our arms around it. And PCI actually, did a pretty good job of making it harder to commit credit card fraud. Of course, I think it's also PCI's fault that we have this ransomware problem today, because wow, it's way easier to make money doing ransomware than it is to try and commit credit card fraud today.
Sorry, my doorbell is ringing right now. If you heard that noise,
I was wondering what that. I wasn't sure.
It was me saying you're darn right.
That's
ding dong, ding dong. You're right, Paul. That's great. So So ransomware is the big threat that many organizations are focused on, and it's kind of the leftover stuff that PCI didn't address. But there's a lot of basic blocking and tackling people can do. Obviously, being very careful with network file shares. It often spreads with that. Having offline backup, true offline backup, and not depending on your cloud provider to back up that stuff, because sometimes the cloud providers don't. So there's a lot of different things you can do. Katie Nichols is actually going to be going over them in our talk, which is in 3 hours and 20 minutes. So I don't want to steal her thunder. One of her big points, though, is the evolving nature of ransomware. And how we have to address that. It's amazing to me. There are professional negotiators now that will negotiate the ransom for you. That's a job category these days. Right. I think it's here to stay. I really want it to go away, but it does seem like ransomware is just a viable attack vector that is making the attackers money. I do, we've had ransomware encrypt some hospital stuff, and therefore, this was maybe 2 years ago, they had to divert an ambulance because that hospital was closed down due to ransomware, and somebody died in the ambulance. I think it was in Germany 2 years ago. Yeah. So, we've had that. Now we've got this Colonial Pipeline situation. If this continues to get worse and becomes more of a threat to life and limb and significant economic damage, I think big time jail time needs to be invoked for this, extradition treaties, and then also possible, special forces action to take somebody out that is doing, really, really bad stuff that is hurting people.
Yeah, so, I definitely think that solves part of the problem, right? In the terms of a deterrent, right, for the enemy. PCI kind of worked in a different way, where you were fined if you were breached and found not to be compliant with PCI. But I think we need to balance both negative and positive reinforcement with companies, right?
Organizations need to defend themselves as best they can. Yeah. That said, it's hard to do it comprehensively, right? But it's doable, and you got to try it. You also need to put in a process so that if it does happen to you, heaven forbid, you know who's going to make the decision of whether you're going to pay or not. Maybe you have a negotiator available. So that's on the defense side, but then there's this sort of deterrent side. And I know that public policy analysts and officials are thinking very heavily about how to beef up that deterrent side.
There's two things. One of them's kind of, funny, but not, I don't want to make light of the ransomware situation either. But one is the double encryption, where now I thought this could be two different groups that just happen to encrypt over the encrypted data. So you got to pay two ransoms. But in one scenario, someone described to me that you use two different keys. 70% of the environment is encrypted with a key. 30%, that's the really important stuff, is double encrypted, right? And so you pay the ransom, you decrypt everything, but that 30%, you go back and they're like, oh yeah, you got to give us some more money if you want those systems back now too. Yeah. And this is what happens when we deal with criminals.
It's true. And the criminal mind, they're amazing psychoanalysts, right? I mean, they're analyzing the psychology of their victims and trying to figure out how to milk more money out of them. Right. I read a report earlier today that said that even companies who are paying ransom to, acting in good faith criminals, they're even then not getting all of their data back on average. So you're paying a criminal who gives you the key and is not trying to do anything bad to you other than get money out of you and wants you to be able to decrypt it. Even then, you're only getting 92% of your data back. 8% still remains encrypted because the crypto malware did something wrong or bad. Right. So buggy code. So you also, in putting together your plan, you have to assume even if you pay the attackers, they might be acting in bad faith, so you won't get your data back. Or even if they're acting in good faith, technologically, there's a good chance you're not going to get all your data back.
That's interesting. The other one is a company was having a difficult time restoring from backups, and the ransomware actors were like, you better pay the ransomware, we're going to leak all your data online. And the company's like, yeah, could you do that actually? Because we're having trouble with our backup. So speaking of the psychology behind it, right?
Leak the data so we can use it. Well, it's an interesting idea that in many environments, integrity is actually more important and availability than confidentiality.
Right. I mean,
confidentiality, it's something we always think of because we have crypto. So that must be the big problem because we have a good solution for it, right? But integrity, which crypto can help with, and availability, those are often more important than confidentiality. It depends on your business, of course.
Yeah, and I think we're really seeing the bubble to the surface that operational security risk be more important than the data security risks. One of the debates we have about PCI, I'm like, it's a data security standard to protect the data. Ransomware is, there's data involved, but they're also playing on that operational risks, as we saw with the pipeline.
Yeah. There's a thing that I see. It's sometimes pretty senior levels of management where they'll say, look, the confidentiality of our data isn't all that important. Who would want our data? It doesn't really matter. And the answer to that is you would want your data. Exactly. That's why you should worry about ransomware.
Yes.
Because if your data isn't available to you, you don't have a business anymore. And I've explained that to people in a nice way, and they're like, oh, good point.
Yes.
Yeah.
Well, awesome. Ed, it was a great discussion. I'm looking forward to your talk at RSA, and everyone should go check it out.
Thanks,
sounds
Paul.
like a great discussion. So always nice to see you, Ed.
Likewise, and thanks to the whole team there. You guys do such a great job, really, for the whole industry. So thanks for all you're doing. This was fun.
Absolutely. Thank you, Ed. Well, with that, we will come back with some more interviews. Stay tuned.